In this video we will look at multicollinearity, one of the most common issues in multiple regression. This matters because it affects how much we can trust the coefficients we estimated. You can go back to the OLS simple and multiple regression videos I have shown you before. Multicollinearity happens when two or more explanatory variables move closely together. In other words, they contain overlapping information. When that happens, the model struggles to separate their individual effects. When multicollinearity is high, coefficients can become unstable. They may flip signs, become very large or very small, or lose statistical significance, even if the variables are actually important. The model still predicts well, but the individual coefficients become unreliable. A quick first way to detect multicollinearity is to look at the correlation matrix. For this, go to Data, Data Analysis, select Correlation, and generate the matrix on a new worksheet. A correlation matrix is a square table, where each row and column represents a variable. To find the correlation between two variables, look at the cell where their row and column intersect. For example, inflation with export growth or unemployment with GDP growth. The matrix is symmetric, so the value is the same whether you read it across or down. High correlations, say above 0.7 or 0.8, suggest potential multicollinearity. The best way to measure multicollinearity is with the Variance Inflation Factor, or VIF. A VIF tells you how much the variance of a coefficient is inflated because of correlation with other variables. To compute VIF, you run a separate regression for each explanatory variable, using the other explanatory variables as predictors. Let's start with inflation. Go to Data, Data Analytics, select Regression. The dependent Y variable is inflation, and the explanatory variables are exports and unemployment. After you obtain the regression table, the VIF for inflation is simply 1 divided by 1 minus the R squared, from regressing that variable on all the other explanatory variables. For easier reference, I renamed the sheet containing the regression output for inflation. I will now repeat the procedure for the second explanatory power, exports. The dependent variable must be on the left, and the explanatory variables on the right, so I need to cut and paste inflation to the right to keep the correct regression structure. Now, I can go to Data Analysis and run the regression as before. We have the regression table with exports as dependent variable, and we'll rename the sheet containing it for easier reference. Now, we can compute the VIF for exports with the formula I've shown you before. Remember that you can get the R squared from the regression table, so this is why it is important to rename each sheet. Otherwise, finding the correct R squared may be difficult. Now let's compute VIF for the third and last explanatory variable, unemployment. Remember, the dependent variable must be at the left, so here we have to make some changes. I will thus move unemployment to the left of export growth and inflation, and then I can run the regression. In the Y range, I select unemployment. We obtain the regression output table. Remember to rename the sheet, as you will need the R square from this table later. I will compute the VIF for unemployment using the formula from before. We take the R squared from sheet UNEMP. And now we have the VIF for all three explanatory variables. A high VIF means the variable is highly correlated with the others, making its coefficient unstable. The model may still predict well, but the individual effect of that variable becomes hard to interpret. A VIF around 1 to 5 is usually fine. A VIF above 10 is a strong sign of multicollinearity. If you find high VIF values, you can remove one of the correlated variables, combine them, or rethink the model structure. The goal is to keep variables that add unique information. And that's how you detect and interpret multicollinearity using VIF in Excel. In the next tutorial, we'll look at dummy variables and how to include categorical information in your regression models. Thank you for watching, and please like the video if you found it helpful.